Good evening, everybody. Welcome to UAMS Grand Rounds. I'm super thankful and excited that you guys have chosen to attend this evening. I hope this discussion is both fun and educational and also leaves you with a little something to think about. My name is Paige Newman. I am an environmental health specialist for the Arkansas Department of Environmental Quality. Today we'll be discussing the feasibility of using wastewater as a source of drinking water and kind of what the process of converting that wastewater into drinking water looks like, and also the cost of converting wastewater into drinking water. Hopefully by the end of this discussion and presentation you'll be a little bit more educated on this process and can give me your thoughts on if you think the U.S. should continue with this process of using wastewater as drinking water, or you think the U.S. should look for more feasible, cheaper options. So what does wastewater include? You may only think of sewage when you hear the term wastewater. I know I did growing up as a kid. But wastewater is another word for used water, so it includes many different discharges. All effluent discharge from homes, commercial establishments, hospitals, industries, etc. are considered wastewater. This includes human waste, oils, chemicals, and even water from washing machines and dishwashers. Also, a part of wastewater is storm runoff. Most people assume that rain that runs down a street during a storm is clean, but actually it's picking up harmful substances that wash off roads and rooftops along its way. So it's not considered clean drinking water after it's hit the roofs or hit the roads or the parking lots. There are two different stages of wastewater treatment process. They're both extensive, but one is a little bit more extensive, and it just depends on how pure you need the water to be and what the water is going to be used for. For irrigation and industry purposes, the process is not as extensive as it is for drinking water purposes. So first we'll talk about what it looks like to treat water for irrigation and industry purposes. There are 3 steps: primary treatment, secondary treatment, and tertiary treatment that are involved with this stage of the water treatment. As a point of reference for the next 2 slides, I will share the processes Point Loma wastewater treatment plant out of San Diego uses. So during primary treatment, water is separated from large particles and then enters sedimentation tanks where chemicals are used to make primary sludge settle at the bottom and the scum rise to the top. Once about 80% of the solids have been removed, the wastewater is clean enough to be discharged into the ocean. Yes, you heard that correctly, discharged into the ocean. Most wastewater that's treated along the coast, though potentially valuable, ends up in the ocean. Keep in mind the U.S. spends billions of dollars on wastewater treatment, but we'll discuss that in further detail shortly. In secondary treatment, bacteria are added to the wastewater to ingest organic solids, producing secondary sludge that settles to the bottom. During tertiary treatment, water is filtered to remove whatever solids remain, disinfect with chlorine, and then remove the salt. So those are the 3 steps that are involved with water purification for irrigation and industry purposes. Most wastewater that is treated is used for irrigation and industry purposes. But there is a more extensive process that the water can go through that can be used for indirect potable reuse. Indirect potable reuse is basically another term for recycling water for drinking water. This recycled water has already gone through primary, secondary, and tertiary treatment that we discussed in the last slide. The tertiary treated water spends time in groundwater or surface water, such as reservoirs, after going through advanced water technologies and before it can be sent to drinking water supplies. So this more extensive treatment process is used for drinking water and uses an advanced water technology, which its first step involves microfiltration that strains out any remaining solids that were not removed in the tertiary treatment process. The second step of the advanced water technology is reverse osmosis, which applies pressure to water on one side of a membrane, allowing pure water to pass through, eliminating viruses, bacteria, protozoa, and even pharmaceuticals. The water is then disinfected by ultraviolet light, which I think is super interesting that ultraviolet light can be used for water purification because it's natural. But also used is ozone and hydrogen peroxide. At this point, water is added to groundwater or surface water reservoirs for an average of 6 months to be further purified by natural processes. Again, very awesome that it's being purified with natural process. So after 6 months, the water is drawn from the reservoir and it is tested to ensure it meets the U.S. Environmental Protection Agency standards for clean drinking water. And I've included a link to the EPA's website for their guidelines for clean drinking water if you guys want to take a look at that, just to get a better understanding of the requirements that it takes for water to be considered drinking water. A little history on what water purification has looked like and the impact that it's made in the U.S. The start of U.S. water chlorination and treatment became known as one of the 10 greatest public health achievements of the 20th century, which is huge. And let me tell you why it achieved that title. In 1908, Jersey City, New Jersey became the first city in the United States to begin routine disinfection of community drinking water. Over the next decade, thousands of cities and towns across the U.S. followed suit in routinely disinfecting their drinking water, contributing to a dramatic decrease in disease across the country. And so here's that impact that led to water purification becoming one of the top 10 greatest public health achievements of the 20th century. In 1900, the occurrence of typhoid in the United States was approximately 100 cases per 100,000 people, which is a lot. In 1920, it had decreased to 33.8 cases per 100,000 people, and by 2006, it had decreased to 0.1 cases per 100,000 people. So in the span of basically a year, it went from 100 cases per 100,000 to 0.1 cases per 100,000, which is definitely a drastic decrease in typhoid cases. First and foremost, water is treated to ensure safety to the U.S. population. Our health is what's most important. Drinking supplies in the U.S. are among the safest in the world, and we want to keep them that way. But even with the U.S. drinking water being among the safest in the world, drinking water sources are still at risk for becoming contaminated. And when contaminated, they can cause sickness from waterborne germs such as Cryptosporidium, E. coli, hepatitis A, Giardia, and other pathogens. That's why it's so vital that all drinking water is treated. Recycling and treating water does not just benefit people's health by keeping them disease-free, but also has environmental benefits. Water recycling provides an additional source of water, which decreases the diversion of water from sensitive ecosystems. Other benefits include decreasing wastewater discharges and reducing and preventing pollution. Recycled water can also be used to create or enhance wetlands or habitats. So, is the benefit of recycling wastewater as a source of drinking water worth the money it takes for the extensive treatment processes? This is where I want you guys to dig a little deeper and give me any thoughts, opinions, questions on this topic, on if you think the US should continue using wastewater for drinking water, or if they should implement imported water and groundwater into drinking water sources, which imported water and groundwater would both be cheaper, but are they sustainable and cost efficient in the long run? That is still a question that is being asked, but it has been proven that water recycling, which means the reuse of wastewater, is a sustainable approach and can be cost effective in the long run. But the treatment of wastewater for reuse and the installation of distribution systems can be initially expensive compared to such water supply alternatives as imported water or groundwater. So one distribution system can cost anywhere from $200,000 to $1 million, depending on the quality of the water that it is taking in. $2.2 trillion. I can't even wrap my head around that. $2.2 trillion. That's how much the US has spent on operations, maintenance, and capital infrastructure of water and wastewater utilities in the last 59 years. That's a lot of money. Like I said, I cannot even wrap my head around $2.2 trillion. But it goes on. 271 billion. That's how much the Environmental Protection Agency estimates is needed for wastewater infrastructure over the next 25 years in the US. While federal government provides some funding through Clean Water State Revolving Fund, according to the U.S. Conference of Mayors, 95% of spending of water infrastructure is made at the local level. Here are the references that I use that I pulled my information from for this presentation. If you guys want to dig a little deeper, they are at your disposal. This is a map showing countries connected to a wastewater collecting system, and at the bottom you'll see the website that I retrieved this from if you want to take a look at that. But that purplish blue color that you see is the countries with the highest amount of their population getting their drinking water from wastewater. And then second, we have the darker blue, which is North America. And then it goes on to the lighter blues, and then even some countries aren't pulling from wastewater at all. You see a lot of Africa not using a system like this just because it is so expensive. So what are your thoughts? Do you think the U.S. should continue spending money on wastewater reuse as a form of drinking water, or begin to look at other alternatives such as imported water that may be a little bit cheaper but maybe not sufficient, a sufficient approach for the long run? So let me know. Email me with any thoughts, any opinions, any questions, and we can discuss this. For more information on the treatment process, I have linked a YouTube video, and yes, it is very old school, but it's only 5 minutes and it kind of runs through what the wastewater treatment process looks like, so you can kind of even get more information. But that's it for today. Thanks so much for listening and joining me in this, and I hope you guys can email me with questions or opinions or thoughts. Thank you.